Hello. So in this video, this short video, we're going to consider how and why scientists measure things. Why do scientists measure things? Make sure we hit the right button here. Scientists use measurement tools, which are units and tools that allow us to measure things like balances and graduated cylinders. They use these things so they can evaluate and figure out the physical world around them. We too use tools to measure things around us in everyday life, when we're acting as scientists or just when we're acting as ordinary people. You can see, I'm sure, if you cook, let's turn this on so I can write. Come on, there we go. If you cook, you may have seen this before. This is a measuring cup, and the units that you use when you measure are usually ounces or cups or quarts or gallons, because in the United States these are the typical units we use to measure volume. We're going to talk about a different type of unit in a few minutes. If you drive a car or you're learning how to drive a car, you measure gas that you put in the car. You measure it in gallons. You don't just put 5 in your car. You put 5 gallons of gasoline. You need to have a unit to figure out what you're paying for and how much gas that you're putting in your car. If you just put 5, you wouldn't know if it was 5 gallons or 5 cups. It makes a big difference in how far the car can go. So the unit tells you a lot about what you are measuring. Now, in the experiments and the activities we did in the previous days, we needed to measure mass and volume in order to learn about density and what made substances float or sink. So measurement is very important. Let's see if we can erase this. Hello. There we go. This is always so difficult. There we go. Oops. So what type of units are we going to use in chemistry? We are going to use the metric system. So since we were talking about volume with gallons and cups and ounces, let's start there. In the metric system, which is used around the rest of the world, but not so much in the United States, to measure volume, which as we talked about earlier is the amount of space that something occupies, we use a liter. That is the base unit, a liter. The symbol for a liter is an L, a capital L. Note that it's a capital. So that's the unit to measure volume, and volume is the amount of space that something occupies. If we're going to measure something's mass, and we talked about mass in the previous lesson, mass is the amount of matter or stuff in something, then we're going to use the unit, the gram. That will be our base unit. The symbol for the gram is G. If we're going to measure the length of something, we're going to use a meter as our base unit. And the symbol for the meter is a small m. So the fact that this is a small m is important because a big M means something different in science. The fact that this is a small g is important because a big G means something different. We're going to use a lot of symbols in this class, and so we need to pay attention to what they are. So these are the 3 base units we're going to talk about today. The meter, which we use to measure length, the symbol is a small m. The gram, which we use to measure mass, or the amount of stuff that we have in something, and the symbol for that is a G. And the liter, which we use to measure volume, or the amount of space something takes up, and the symbol for that is a capital L. Let's see if I can do this any quicker. Tap, 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 tap. It's not. Yoo-hoo. Clear. Here. Nope. There we go. So we don't always measure things in grams. A gram, as you've seen from the activities we did in the past few days, is not a lot of stuff. If you had to measure the mass of your car and you measured it in grams, it would be a huge number. Your car has a mass of a lot of grams. I don't know what it would be. Um, but it would be hundreds of thousands of grams, let's just say. And that's a big number to write. If you had to write the mass of your car and it was 432,713 grams, your hands would get tired. So when we have to measure something that's very large, we don't use a gram. We put, there we go, hey, come on. We put a prefix in front of that, and we make it bigger. So if we want to talk about 1,000 of something, we put a K in front of our G, and it becomes a kilogram. So we can make a measuring unit bigger or smaller in the metric system by putting a prefix in front of the base units that we just talked about. So if we wanted to measure something in kilograms, and I think I should look this up before I say it, a kilogram is 2.2 pounds, but it might be the other way around. But a kilogram has a lot of mass. A kilogram is, you're putting the K for 1,000, that means 1,000 of something, in front of the base unit, which is the gram. So a kilogram is really just 1,000 grams. They're the same thing. A kilogram is a unit that is equal to 1,000 grams. So if your car weighed 432,713 grams, it would only weigh 413.7 kilograms, because that's 400. Did I say that backwards? 13,000 divided by 1,000. Let's erase this. And the other prefixes, these are some other metric prefixes. There are more, but these are the ones that we're going to talk about in our next class. If we want to talk about 100 of something, we use the prefix hecto. And the symbol for that is a small h. So a hectogram would be Hg. A hectoliter would be HL. This would be equal to 1,000 grams. This would be equal to 1,000 liters. So it's a bigger unit of measurement. If we want to talk about 10 of something, we use a deca, which is 10 of something. The symbol for that is DA. Sometimes we want to use a smaller measurement. In that case, we can use a deci, which is 1/10. And note that 1/10 is either 1/10, can also be written as 0.1, or centi. You've heard of centimeters before. That is 1/100th of something. 1/100th or 0.01. The symbol for that is a C. So a centimeter is cm. That means 1/100th of a meter. And if you look at a meter stick and you count up the little centimeters on it, you'll find that there are 100 in a meter. And we can have a millimeter, which is 1/1000th of something. And the symbol for that is an M. And when you were measuring volume the other day, you used milliliters, which is 1/1000th of a liter. And that is the M for the 1/1000th and the L for the base unit, which is the liter. And you come up with a small unit of measurement, a milliliter. So these are the symbols that we're going to work with in this class. The ones we will focus on most will be the kilo, which is 1,000 of something, the centi, and the milli. The other ones are important, but we won't use them as much. And you can put these prefixes in front of any base unit. So, how do we know how long a meter is, or how much mass is in a gram, or how much volume is in a liter? So as an international community, we keep standards so that we know that every time we measure a meter stick, it actually is a meter long. Every time we mass a gram, we know that it actually is a gram, the same amount of stuff that we measured the day before and the day before. Imagine if you took a meter stick and you made a copy of it. You measured it out on a piece of paper and you cut out that length, and then you use the copy to measure make your measurements. And then your friend needed to measure some meters, so you made a copy of that copy and gave him the copy. And you kept doing that. Well, after a while, by making a copy of a copy of a copy, the new meter, the 10th copy, might not actually be the same length as the original one. So the scientific community keeps standards. There's actually, in 1889, They took a block of platinum and another metal. I have to look up what it was. And it was about 2.2 pounds, and they designated that as a kilogram. And so that stays in a protected spot in Paris, somewhere in France. And so we always can go back to that to compare to make sure that we know our kilogram measurement really is a kilogram. And it was made of platinum and iridium. Similarly, this picture is when they designated how long a meter was going to be. And I don't know, they were trying to be creative back then. They decided the meter was going to be 1/10,000,000th of the length of the Earth's meridian, so the Earth's longitude, as it goes through, am I saying that correctly? The meridian, through Paris, from the North Pole to the equator. But they didn't know how long that was, so they had to kind of estimate how long that would be, which they did. And so they came up with a measurement that was 1/10,000,000th of that, and they made a piece of metal that was also made of platinum iridium, and they made markings on it to show how long a meter was going to be. And that was used as the standard, so the standard of measurement. Today, we don't use it as the standard. We say a meter, the standard measurement for a meter, what we compare all meters to, is the length of the path traveled by light in a vacuum in a very short interval of time. So this is how we measure our standards and make sure our measurements don't change over time. That's not as important for what we're going to be working on in the next few days. I just wanted you to know it. But what we want to remember, let's erase this, is that when we measure things, we use a base unit in the metric system, and we're going to be talking in the next few days about meters, grams, and liters. And if we need to adjust those units, for example, you would not measure a football field in millimeters because it would take you a long time. You measure a football field in meters. We usually do it in yards because that's bigger. So if you want to adjust these units, you then add prefixes. And these are the prefixes that change the length of the measuring unit when you add them in front of the base unit. That is all for today. Let's turn this off.